In this video, we're going to define reference angles and talk about how you can find them, okay? So let's start with this. We say, what is a reference angle in the first place? Well, the values of trig functions of angles greater than 90 or less than 0 can be found using corresponding acute angles called reference angles. And that's all fine and everything, but we say, basically in a nutshell, what that means is, if I wanted to find, say, the trig functions of an angle that's, say, bigger than 90 or maybe even negative, I could do it using these nifty little things called reference angles. So if they're so nifty, then what the heck are they, okay? So by definition, we say let theta be an angle in standard position. As a matter of fact, let's just go ahead and sketch a picture of some random angle theta in standard position here. So we say I have some angle theta. Let's have it terminate, say, in the second quadrant right here. Da, da, da. So here's our angle theta. We say that this angle theta actually has a reference angle that is associated with it. So we say its reference angle is the acute angle theta prime, okay? So the first thing we need to learn is this. Given an angle theta, every angle theta has a reference angle that's associated with it, and we refer to it as theta prime, okay? You just write it with a theta with a little apostrophe. But we say it's formed by the terminal side of theta in the x-axis, okay? So here's what I'd like to mention about this. Matter of fact, if we pull out like maybe a lighter cerulean here, we say, okay, I can obviously see the terminal side of my angle here, theta. This is the terminal side, but we say it is the acute angle theta prime formed by the terminal side of theta, so this blue thing we just highlighted here, and the x-axis, okay? So if the reference angle is really the angle between my terminal side and the x-axis, the question is which one is it? Because I suppose I could form an angle over here or I could form an angle over here. Simple fact of the matter is this: reference angles are always acute and they're always positive. That's a side note, but they're always acute, which means this: if you want to find the reference angle of a given angle, just kind of mentally highlight its terminal side in your head and then drop down kind of an arc back to the x-axis. This will be its reference angle. It is the angle that we just formed between the terminal side and the x-axis. You'll notice that this angle in blue here, it is acute, okay? And I do not care which way that we rotate. So we'll say reference angles are always positive. So the nice thing that we can say about reference angles is this: theta prime is always some number between 0 degrees and 90 degrees. Or we could say in radians, theta prime is always between, oops, sorry, I almost got ahead of myself there. Theta prime is always between 0 radians and half of a pi radian, so, or pi halves. So here's what we want to do. We want to find reference angles quite a bit. And as a matter of fact, they're very, very simple to find. It's just taking some practice to do this, okay? So here's what I'd like to try out. Let's try to find some reference angle for the given angles that we find down here, okay? So we say find the reference angle theta prime for each angle theta. Let's go ahead and start by doing this. Let's sketch an image of our angle theta in standard position. So we see a 320 degree angle here. Well, using the fact that one full time around would be 360 degrees, then 320 must be 40 degrees short of this. So, we'll draw, actually let's do it in blue here. This would be roughly our theta right here. Da, 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 theta. Okay, so here's theta. Theta is 320 degrees in measurement. The question becomes now, so what's its reference angle? And so a reference angle, remember, is formed between the terminal side of our initial angle, theta. I'll try to sketch over this again. So here's our terminal side in the x-axis. So we say its reference angle, you could think about it this way, is the angle that's formed between the terminal side directly back down to the x-axis. And we'll label this theta prime. Now the thing is, we do actually need to find out what this angle is. Now you'll know, notice, at least I hope you notice, that we did mention earlier that this is 40 while I was sketching the original angle. But the fact that you were able to find your way to the original angle kind of allows or helps you to find the reference angle, because you had to think about this anyways. So we'd say if theta is 320 degrees, then its reference angle is this angle 40 degrees. That is its reference angle. Okay, so what if we have like a radian measurement, which is negative 5 pi 6 here? Well, one thing I do want to mention, don't forget that pi radians is 180 degrees, so a sixth of this would be a 30 degree angle. This is like saying I have negative 5 of these 30 degree angles, essentially. So if you want to interpret this another way, this would be a negative 150 degree angle. We can go ahead and graph it like that if we care to. I guess I do care to in this instance, but a negative angle, which is going to rotate clockwise, we say 150 degrees. I know that I have to go at least negative 90 degrees, but I'm not quite going to go all the way to 180 degrees here. So we'd say, well, negative 150, that would be 30 degrees short of negative 180. 30 degrees is roughly, it's like that right there. But we'd say, here's our original angle, theta, in standard position. So let's go ahead and find its reference angle now. We'd say its reference angle is between the terminal side here and the x-axis. So its reference angle here, theta prime, actually comes out to be 30 degrees. And you'll notice that I called it positive 30 degrees. So if theta is negative 150, then theta prime is 30. Okay. Let's go ahead and finish these other two up here really, really quickly. We say negative 120. If I had to get there, we say negative 90 degrees. Well, I'd have to go like 30 degrees past this. So we'd say negative 120 degrees would be this angle right here. We'd say this is theta. It is negative 120 degrees. But to find its reference angle, remember the reference angle is formed between the terminal side of the angle that we had to begin with, so between this side here, and the x-axis. So straight back to the x-axis here, we say this is our theta prime. And knowing that this was 30 to begin with, this is not our reference angle, but knowing that would actually help us to determine that this must be a 60-degree angle right here. So for a negative 120 degree original angle, let's do this. Switch back to green. We get a positive 60-degree reference angle. And then last but not least, we say 2 pi thirds. Let's go ahead and sketch this guy out here. 2 pi thirds. Remember what we know about pi. Pi is 180 degrees, so to have 2 pi thirds is like having 2 thirds of pi. But a third of pi is a 60, so this is like two 60-degree angles. We've got 120 degrees. So if we were to sketch this, our 120-degree angle would be about right here. We get this guy right here. So we'd say theta equals 120 degrees. But we say, well, okay, so what's its reference angle formed between the terminal side and the x-axis? It would be this angle here. And since this is 120, we could look at this as being like 60 degrees shy of the x-axis. So this is just kind of a quick and easy definition of the reference angle. It's just formed between the terminal side and the x-axis. And just know that they're always acute and they must always be positive. Cheers.